Hello everybody, this is Orash, a doctoral student of industrial engineering at Lamar University. Today I'm going to talk about how we can create a Grasshopper beam engine, how we can assemble it, and how we can use knowledge about the design for manufacturing and design. Alright, as you can see here, first of all I'm gonna talk about to CIM and GBE. GBE means Grasshopper Beam Engine, and then I'm gonna talk about the part description. I will show you all 23 parts. Then I'm gonna talk about how we can assemble these parts together, and then the next step I'm gonna talk about DFM and DFA. As introduction, first of all, we should know how we can start, which software we are dealing with. I choose CIM because I believe it is the most powerful and flexible 3D CAD software on the market. Okay, after choosing the software, you should know what you want to create. So I choose Grasshopper Beam Engine because through creating profile of this engine, we can quickly and easily create 3D models of any parts and also assemble all parts as well. Sorry, I'm talking about the main connecting rod, crack connecting rod, cylinder block, flywheel and valve, flywheel supports, piston assembly, valve assembly, bush and spacer, axle, and the last one is the shaft. And then you can have a Grasshopper Beam engine, as you can see here. Okay, I'm gonna tag here in the picture. As you can see here, this is the base. Then you should put this axle. This is the flywheel support. This is the flywheel, and then we put this one, as a holder for flywheel. And in the right of the picture, you can see the piston and cylinder. And at the end of the slide, I put the animation of this thing, and you can see how this beam engine works. So just wait for a little bit. And this is for a crank, and you can see whenever the flywheel works, it goes down, and this part goes up, and so on. Okay, after creating a profile and making it curious, make all parts and assemble all parts, you have to support your products. If you want to increase your customer satisfaction, if you want to increase your profit and increase your cost, you have to do these disciplines. DFM and DFA are the integration of product design and process planning into one common activity. For example, whenever we want to design for assembly, we can redesign our model and reduce the total number of parts. With these approaches, with this approach, you can reduce. You can see here, reducing the parts. Less parts implies less purchase, inventory, handling, processing time, development time, equipment, engineering time, assembly difficulty, service inspection, testing, and so on. So if you redesign your model, and if you be able to reduce parts, the number of parts, you can reduce your cost and increase your profit. Redesign crank connector rule. So in the modified connector, there is not any extra pins on board. So the second approach, the second role is standard components. Always standard components are less expensive than custom-made items. As you can see here, the left picture is about the custom-made item, and the right picture is about the standard component. The high availability of these components reduce product lead times. Also, the reliability factors are well. As you can see here, this is a custom-made item, and this is the standard component. This is the and the last one. I think, in my point of view, all parts should be assembled from one direction. As you can see here in the left picture, parts are assembled from different direction, from above, top, bottom, horizontal, vertical. This thing makes your model more complicated. Sometimes it's like wasting your time. But at the right of the slide, you can see the modified assembly. Parts are assembled from one direction. All of them were assembled from the vertical direction. See, all of them are assembled from vertical direction. All these disciplines, you can reduce the errors, reduce your costs. You can redesign the model. It makes your product looks better, and also you can increase your customer satisfaction. Based on what I have discussed above, we can conclude that modified Grasshopper beam engine could be able to meet customer desire, while modified product leads to significant reduction in production costs without comparison product time to market goals. DFM and DFA have been used by many companies around the world to develop creative product designs that use optimal. I'm so sorry. The flywheel works. Okay, the flywheel works. This crank goes up and goes down, and cause the piston in the cylinder, the piston goes up and goes down into the cylinder, and it makes power here, and these things here is for output. For example, if this is a beam engine, so the output is beam. Thank you for your attention. I would be more than happy if you have any questions, so you can